Thanksgiving break.
I can't wait for Thanksgiving break either. All right. Well, as you can see, I've got some guests. And so welcome to Chapter 5, Pre-Algebra. It's been a little while since we've done flip videos because we spent all that last week getting ready for the big Chapter 4 test. But we are ready to dig into Chapter 5. And because we kind of spent so much time, we're going to dig in hard and fast. So we're going to do a video tonight on both lessons 5.1 and 5.2, which is really just good whiz-bang introduction to fractions. This is really what we're going to be working on all Chapter 5. Now, my three guests, I have three of them, all gentlemen from the 6th grade that are joining me today, and we're going to get a sneak peek video. There we go. So there is a sneak peek video of the mystery guests for today, and so let's get right into the math.
Wait.
Now, what?
I'm here sponsoring Average Joe's. And go Average Joe's.
Both of us are sponsoring.
Okay, yeah, the seventh graders that are watching this are really excited about that. All right, let's get right into the math here, guys. All right, focus. I need everybody's focus. All right, so let's start out. We're going to actually back up a little bit. Last chapter we talked about GCF, and in a couple of the classes I accidentally got confused and started talking about LCM because that's actually something that we just did in one of my other classes. Okay, so first of all, least common multiple is what LCM stands for. Okay, and what it basically means is we need to find, so if I give you two numbers, the least common multiple is going to be the smallest number that both of those numbers go into. So, oh, sorry, I misspoke. Multiple, that should be an E. Okay, so we're looking for a number that is a multiple. So let's quickly talk about multiples. So multiples of 3 would be things that 3 goes into. So it's like counting by threes. 3, 6, 9, 12. A lot of times when we do our classwork in class, I'll say things like multiples of 2 or multiples of 4. So multiples of 4 means do which problems? 4, 8, 12, 16. You guys got the idea. All right, so if I was looking for the least common multiple of, let's say, 4 and 5. Okay? So what's the first number that both 4 and 5 go into? So one way you could do this is you could just write out all the multiples of 4. 16, 20, 24, and you should really have commas here. And all right, there we go. And then for 5, I get 5, 10, 15, 20. Oh, wait. Look, 20's in both lists. There's the least common multiple. And for small numbers, you can do this. Just like with GCF. You can just GCF had 3 methods. One was write out all the factors. This time we're going to write out all the multiples. Okay? One way that we did greatest common factor was to do prime factorization. There's also a way we can do least common multiple that way. But you're right. The cool way to do LCM is with division letters. Okay, so let's pick some more interesting numbers. Let's pick, say, the numbers 20 and 32. All right, so let's do a good old-fashioned division ladder like we're doing GCF. What goes into 20 and 32, guys?
2.
2 does, okay. 2 and you get 10 and 16. What goes into 10 and 16?
2.
Take another 2 out. And you get 5 and 8. What goes into 5 and 8, guys?
Nothing.
So you take 2 times 2 and you get 4 is the GCF, except this time, now that's where we used to stop. But now, we're going to multiply across the bottom row. Guys, I need y'all focus here. Too much talking. Okay, so multiply across this bottom row. So you multiply the GCF times the 2 remainders. 4 times 5 is 20. 20 times 8 is 160. Now let's test that out. So that is supposed to be the LCM. Now take 20. Does 20 go into 160?
Yes.
Yeah, it goes in 8 times, right? Does 32 go into 160? Yes, it does. It goes in 5 times. Okay? And so 160 is, in fact, a common multiple of both 20 and 32, and it turns out that that is actually the smallest number like that works. Now, that doesn't mean it's the only one. 320 would work. 20 goes into 320 16 times. Obviously, 32 goes in 10 times. Basically, any multiple of 160. 480, 640. Once you find it, any of them will work. And also, if you take 20 times 32, you'll get 640. That is a common multiple, obviously, but it's not the least, right? All right, so that's the idea. So least common multiple. Well, all right, now hold on a second. On that opening screen, guys, I said that we're going to talk about fractions. So why would I bother talking about least common multiple when I'm getting ready to dive into a bunch of fractions? Well, it turns out that the least common multiple, when you're dealing with fractions, if I have 2 fractions, like 1/4 and 3/10, if I want to add them or subtract them or compare them, what do I have to find first before I can do that?
They're common denominator.
I have to find the least common denominator. Those both start with the same first two letters. They're both acronyms. Do they have anything else in common?
They're the same.
They both go with 20.
In both cases, it is 20. You're right, Cole. Ooh, sorry. All right, there goes one of the guesses. Wah, wah, wah. Well, I think that one was pretty obvious. Yeah. Okay. So anyway, all right, there's one of the guesses given away. Okay, I've tried not to give the other two away. Yes. All right. So, but Cole's exactly right. The LCM of 4 and 10 is 20. And the lowest common denominator of 4 and 10 is also 20. And it turns out he's exactly right. The least common multiple of the two denominators is the lowest common denominator. So the reason we introduced this lesson talking about least common multiple, God bless you, Cole, is that finding the lowest common denominator for two fractions is basically the same thing as finding the least common multiple. All right, so let's get right. All right, with all of that introduction, we need to really dig into 5.1 now. So 5.1 is actually called comparing fractions. So let's take the fractions above. If I'm comparing 1/4 and 3/10, what I mean by that is decide if the first fraction is less than the second one, greater than the second one, or equal to the second one. Well, there's a couple different ways we can do this. Okay, but the lowest common denominator way would say, look, rewrite these fractions with the same denominator. All right, if you do that, 4 goes into 20 how many times, guys?
5.
5. So do we all agree that if I multiply the top by 5, that 5/20ths and 1/4 are equivalent fractions? And similarly, I can do the same thing over here. If I double the bottom, what do I have to do to the top?
You have to
Double the top. And so which is bigger, 5/20ths or 6/20ths? And clearly the answer at this point is this. So that means 1/4 was less than 3/10. So this is you doing comparing fractions using common denominators. Okay. The other way that I really like is is similar to this. It's actually quick and it's easy. It's called the crisscross method. And what you do is you always start in the bottom corner and you go up. So 4 times 3 is 12, and 10 times 1 is 10. And if 10 is less than 12, then 1/4 is less than 3/12. So then you just compare these two numbers, and that'll give you the answer. And actually what's happening when you do the crisscross method is you're using a quick common denominator. We'll talk more about that in class, but that's enough for the video. All right, so comparing fractions. There's a third way to compare fractions, and that it takes a little bit longer, but if you have a bunch of them, or if you have a number line already happening to kind of laying around, you can graph the points and do it that way. And so I'm only going to go from 0 to 1/2 here, because both of these fractions are less than 1/2, right?
Yeah.
All right. So if that's 0 and that's 1/2, this point right here would be what? 1/4.
1/4. Yes.
All right, and that should be enough. 1/4 is one of the fractions, so that's where that one goes. So the question is, where does 3/10 go? All right. Well, if I divide, let me change colors here. If I divide, ignore the 1/4 for a second. Actually, let's take that out for a minute. Let's take it out because we know where that one goes.
Yeah.
Let's divide from 0 to 1/2 into tenths. If I divided it into tenths, this would actually be 5/10 right here.
Yeah.
All right, and so what I'd have to do, hold on, I got to put the tenths in. Let me put them in.
2 tenths.
All right, so this would be 1/10, 2/10, 3/10, 4/10, 5/10. Okay, now let's go back. Let's put the 1/4 in. The 1/4 goes right smack dab in the middle. And where would 3/10 go? Well, 3/10 is this blue tick mark right there. And so, again, we can see that 1/4 is just a little bit less.
Tiny.
Just a tiny bit, right? Is a little bit, tiny bit less than this tick mark right here, which is 3/10. Okay, so there's 3 different ways to order and compare fractions. You could do common denominators. You could put them on a number line. And you could also do the crisscross method. Let's back up for a step. What are the 3 different ways to find the lowest common or the least common multiple? Well, we could write out all of the multiples until we find one that's in both of them. We could do division ladder, or we could do the prime factorization trees, which we're not even going to get into in the video, but that's a third way. So there's 3 ways to find the least common multiple. There's 3 ways to compare fractions. So now let's move on to 5.2, because guess what? In 5.2, what we're going to do is we're going to change fractions into decimals and decimals into fractions. Now, we've found this nice kick of 3 ways to do everything. This time we're not going to do that. But this one is really cool because we're going to learn how to change fractions into decimals, and we're also going to learn how to change decimals into fractions. All right. Now, which do you think is easier? Changing fractions into decimals or decimals into fractions?
Decimals into fractions.
Why?
Because for decimals, you just have to read it and reduce it.
Yeah, he's exactly right. I'm trying to draw a frog here. Okay. All right. So that's supposed to be a little frog. Okay. And a frog says, ribbit, ribbit. Well, what it actually is saying, frogs are actually really good at math. Most people don't know that. What it's actually saying is read it, reduce it. Read it, reduce it. If you don't believe me, go find a pond and sit and listen to the bullfrogs, and you'll hear that they're all saying, read it, reduce it. So what I mean by that, suppose we have a decimal like 0.15. Okay, now we say 0.15 in class, but if you were back in Miss Haynes' class, she'd be like, don't you say that like that. And she would instead force you to read it the proper way, which is actually mathematically correct. What would she have you read that as? That is 15 hundredths. And that's exactly how you change a decimal into a fraction. If I said 15 hundredths, you might just as easily have thought I meant the decimal, or you might have thought I meant this fraction. And then 15 over 100, the second part, you're right, Cole, is to reduce it. Take a 5 out, you get 3 over 20. Okay, so that's that direction. So read it, reduce it is how we're going to change decimals into fractions. So how do we change a fraction then into a decimal?
Divide it.
Yep, you divide it. Okay? It's just a long division problem. So if you were unlucky enough to get a 3 out of 20 on a quiz, what's your grade? Well, all you do... Yeah, no kidding. All you got to do is take 3 and divide it by 20. Now, obviously, the big number is going to go out front. We know that. Okay, we're expecting that because 3/20 is a pretty small fraction. So what we're going to do is we're going to do division here. I don't know why that's... Hold on, let me turn this down a little bit. All right, and so 20 goes into 30 one time, agreed?
Agreed.
1 times 20 is 20, and we're going to subtract, and we get 10. Okay, 10 is less than 20, so far I'm doing well. By the way, we're doing does McDonald's sell cheeseburgers? Okay, so 20 goes in, bring down the 0. 20 goes into 100 5 times, and that's exactly 100. Again, put the minus sign out there. You get a remainder of 0. Some people like to make us happy 0, right? And we're done. And so there we go. So let's go back to that last screen. When we divide 3 by 20, what do we get? We got 0.15, which is exactly what we started with, right? So we should be able to go both directions, changing a fraction into a decimal by dividing it, changing a decimal into a fraction by reading it and reducing it. Now sometimes, let me throw one more out there. Sometimes we're going to take a fraction and we're going to go to reduce it. So we're going to take, or divide it, we're going to put the 5 inside, we'll put the 6 outside. Okay, let's put a couple decimals up there. Alright, how many times does 6 go into 50, guys?
12.
12.
No.
No. It goes in,
no.
6.
6 goes into
times.
50. Think about your math facts. Right, 8. So 6 times 8 is 48. Subtract and you get 2. Alright, now bring down the 0. 6 goes into 20 3 times, and that's 18. Subtract. Oh, wait a second. I get 2 again. Bring down another 0. Okay, 6 goes into 20 3 times. Okay, and if you just heard my second mystery guest, he just said, and that's okay, he said repeating, and that's exactly right. No matter how many times I do this, I'm just going to keep getting 3s up here. Well, what am I eventually going to do? Well, I'm going to get tired of writing 3s. So this is 0.83 with a bar on top. So when you divide a fraction, you can get one of 2 different kinds of decimals. You can get a decimal that ends, which is called a terminating decimal, or you can get a decimal that stops and repeats. All right, well, guys, it's already 13 minutes. Hold on. So let's go ahead and wrap this up. So it's time to do the big reveal of my mystery guest. So I already gave away that. No, we don't need a drum roll. So I already gave away that one of my guests was Cole. And there we go. And so Ryan Sullivan, or Solly, was the other guest, and of course J.P. Thomas. So thank you, gentlemen, for a great video, and everybody, thanks for watching. And we've just wrapped up 2 different lessons, 5.1 and 5.2, and I think we've got off to a good introduction of fractions. So I'll see you in class tomorrow, and we'll practice this. Take care.
Bye.
Thanks, guys.